has been built. And it isn't just environmental reasons, it's economics. They're an economic disaster. And unfortunately, the huge economic costs are hidden from the public. The public do not find out how much they're paying for these darn things until it's too late. I'll give you an example. Ramsey County. I believe, if I haven't been misinformed, Ramsey County had a subsidy of $14 million a year to pay for that incinerator. $14 million of taxpayers' money each year for 20 years. Well, 20 times 14 is $280 million going into destroying resources and wasting energy and wasting time fighting global warming. Could you imagine what kind of recycling program you could have had in Ramsey County with $280 million investment? Incinerators are poor investment. Most of your money spent on incinerator goes into complicated machinery, into a few pockets, not many pockets, and it leaves the community. You don't have any incinerator builders in St. Paul or Minnesota. These are going to be companies from other countries, other states. The money spent on the alternatives, on the other hand, goes into jobs and stays in the community because you're dealing largely with low technology. Think of an incinerator as three boxes. The first box is the furnace and the generator. And that converts hundreds of tons of trash each day into trillions of tiny particles and gases. Now you need another box. You need another box, which we call air pollution control devices, to do your best to capture these tiny particles and these toxic gases. Now today, the cost of that second box is equal or more than the cost of the first box. Then the third box that you need is a depository somewhere to put the ash that you have captured in this process. The fly ash is the ash, the particles which are captured in the air pollution control devices, and the bottom ash, which is left on the grates. Now, the thing to notice here is that number 2 and number 3 boxes are totally unnecessary unless you build number 1 box. Here is a schematic of an incinerator, and you'll notice the bottom ash is the ash that falls through the grates. That's about 90% of your product, and the fly ash is about 10%, and that is captured in the ever-increasing, expensive and complicated air pollution control. Looking at ash management around the world, in Germany and Switzerland, fly ash is put into nylon bags and placed into salt mines. In Japan, some of the incinerators actually use up a lot of energy to vitrify the ash and make the metals less leachable. In the Netherlands, this is a play by Kafka. Having spent a fortune on these incinerators to capture the fly ash, they put the fly ash into asphalt, spread it on the surface of their roads, and the bottom ash is used in the roadbed. So the next time, if you're ever in the Netherlands and you drive there, you're driving on their ash landfills. Now Denmark, beautiful green Denmark, has a superb solution for their ash. They send it all to Norway. Norway has an island just outside Oslo. It's an island which is made of solid clay, and they just dump all their hazardous waste and all the ash from their own incinerators and from the Danish incinerators. In the United States, if you ever want to be convinced of how awful the science is underpinning incineration, this is it. In the United States, we allow the bottom ash to be mixed with the fly ash before it's tested. And the result of that dodge is that the ash passes now to any toxicity testing, which is a leachate test. The lime in the fly ash is essentially protecting the bottom ash from failure. And now this ash goes to regular landfills. It's even used in some places as daily cover. It's an absolutely atrocious thing. Even more atrocious is that once you've given the name of this, you've told people it's non-toxic, then your workers who work in these plants are probably more cavalier about the way they handle this ash, and yet it's incredibly toxic material. It's got toxic metals in it, and it's got dioxins and furans and all kinds of other nasties. And I don't think we're doing a very good job of protecting those workers. Incinerator air emissions. You've heard about the carbon dioxide, but that's not the real contribution to global warming. The contribution to global warming from incineration is you have to go back to square one. If you go into reuse, recycling, composting, you don't go back to square one, and that's where the CO2 is saved. As far as the acid gases are concerned, one of them, nitrous oxide, is a global greenhouse gas, and the other one is neutral. When it's produced, the nitric oxide is neutral, which means you can't use the cheap methods of acid gas control. You have to go to something called DeNOx equipment, and that's expensive. It uses either ammonia or urea to capture the nitrogen oxides. The toxic metals are a formidable problem because they're elements, and elements, as you probably know from your first chemistry lesson, although most people want to forget the chemistry they ever did, are indestructible. And so whatever toxic metals go into the incinerator come out of the incinerator. The best you can do is they end up in the ash. The worst, of course, is they go into the air. Mercury in particular is very formidable. You only need 1/3 of a gram of mercury to contaminate a 25-acre lake, 1/3 of a gram, to the point that you can't eat the large fish. It bioconcentrates like crazy. And they're only required, the law is that you remove 85% of the mercury. That means that 15% is coming out, contaminating your fish, and eventually contaminating your babies. Also in the burning process, we generate thousands, and I do mean thousands of new compounds. Dioxins and furans are the most toxic of all of those compounds, and in fact the most toxic substances that we've ever made in a chemical laboratory. And the irony is we can make these substances simply by burning household trash. And you can do it in your backyard if you chose. Your backyard burners produce dioxins as well. Now, complicating this still further is that these toxic metals and dioxins come out on the surface of tiny, tiny particles, nanoparticles, less than 1 micron. I saw an email today responding to the presentation I gave a couple of days ago to the RAP folks, saying, more or less agreeing that nanoparticles was a problem, but it's not a new issue. Now, I absolutely agree with this person who said that. Nanoparticles is not a new issue. We've been producing nanoparticles in high temperature incineration for a long time. What is new is our understanding of their devastating biology. And so over the last few years, largely as a result of the development of nanotechnology, we've now got a new science called nanopathology, which is the exquisite, strange, bizarre biology or biological behavior of nanoparticles. Now, first of all, let's appreciate how small these wretched things are. The average width of a human hair is 60 microns. We regulate pollutants from stacks of incinerators at 10 microns. These are cannonballs compared to the particles less than 1 micron. So we're concerned about these particles over here. And we regulate at this level. And this level does not give you any idea of just how much of these. And let me give you an example of that. Alan showed me a study just before the meeting in which they moved from burning coal to burning wood or biomass. Switchgrass. They went from burning coal to switchgrass. And what they found was that the particulate levels was the same, the total. But there was a vast increase in the nanoparticles. In other words, there was an enrichment of the smallest particles. And that was new to me. So, you know, even with what you might think was a very safe biofuel, you're going to get more of these nanoparticles out of there. Okay, now, as I said to the RAP meeting the other day, nobody, absolutely nobody in this world should be promoting incineration unless they can read this paper from the Environmental Health Perspectives, which is one of America's leading environmental health journals. They must be able to respond to this rationally. I'm looking forward to, after all, you've got $4.5 million to look at these issues, so hopefully some of that money can be used into a very careful analysis of this paper. I was absolutely shocked by this. There were things in there which I had no idea about.